Hi, welcome to this video. In today's video I'm going to do this problem. This is the International Math Olympiad of 1966, problem number 4. I'm going to prove this expression for all integer n. X is a real number, x different than k multiplied by p over 2 to the t equal to 0, 1, 2 and so on until you get the last term n. K is an integer as well. So now I'm going to use this one as a tool. This expression I'm going to prove cosine 2x equal to 2 cosine squared x minus 1, and then I'm going to prove the second expression, okay, in order to prove this expression, okay, which is sum of 1 over sine 2 to the kx equal to cotangent tx minus cotangent 2 to the nx. Okay, let's start with the first one. Before I start proving this one, I will use this one as a tool. I'm going to prove it first, prove the first expression, okay. I'm going to use the trigonometry formula here. I'm going to use this one, cosine a plus b equal cosine a multiplied by cosine b, okay, minus sine a multiplied by sine b, okay. So cosine 2x equal to cosine x plus x, okay, which is cosine x multiplied by cosine x. I'm applying this one as you see it, okay. Cosine x multiplied by cosine x minus sine x multiplied by sine x, okay. This one is a cosine square, okay. This one minus sine square, okay. As you know, cosine x squared plus sine x squared equal to 1, right? We have these two formulas. Now I'm just insert this one into here. So this one is giving us cosine square x minus this one sine square x equal 1 minus cosine square x, okay. Just cosine, just adding this one on this one. So cosine 2x with this minus outside become minus 1, minus multiplied by minus is plus cosine square x, okay. Just adding cosine x plus cosine x square, which is 2 cosine square x, okay, minus 1. Now the first expression is proved. Let's move on to the next step, okay. Now in the second step I'm going to prove this one, 1 over sine 2x equal to cotangent x minus cotangent 2x. I'm going to use it as a tool in order to prove this expression, okay. Cotangent x minus cotangent 2x, okay, equal to what is cotangent x, as I have mentioned. Cotangent x, I have it in this formula. I have cotangent x equal to cosine x over sine x, cosine x over sine x, okay. Same thing with cotangent 2x. It will be minus cosine 2x over sine 2x, okay. So let's call it capital A. Capital A equal to this one, cosine x over sine x minus, I already proved this one, okay, in the first equation, cosine 2x equal to 2 cosine square x minus 1, which is 2 cosine 2x minus 1. But I still have a problem with this one. Sine 2x equal to what? So this one, I can prove it again. We have sine a plus b equal to sine a multiplied by cosine b plus cosine a multiplied by sine b, which is 2 times sine a cosine b. Okay, as you see here, a equal to b because we have sine 2x. So that's mean sine 2x by replacing a equal to b equal x. Okay, equal to x. So this one, I'm just verifying this one by replacing a equal to b equal to x. Sine 2x equal 2 times sine x multiplied by cosine x. So now I will just now this one equal to this one. I'm just replacing it. 2 sine x multiplied by cosine x. Okay. Now to calculate this fraction, these two fractions, I'm going to multiply cosine x by 2 sine x cosine x minus sine x multiplied by 2 cosine square x minus 1. So this one is giving you 2 sine x multiplied by cosine square x minus 2 times sine x multiplied by cosine x square plus sine x. With this minus and minus it become plus, with this minus it stay the same minus. Okay, over the whole thing, which is multiply sine x by 2 sine x cosine x, which is 2 sine square x cosine x. Okay, so 2 sine x cosine 2 square x, it will be cancelled out. Okay, so what's left? Sine x. So this one equals sine x over 2 times sine x cosine x square. I have square. So this one I'm going to simplify sine x by sine x. Okay, so it become 1 over 2 sine x cosine x. What is this? You see, 2 sine x cosine x is sine 2x equal 1 over sine 2x. Okay, now this one I proved the second equation as you see it here. So let's move on to the third step. Okay, step, I'm going to prove this equation. Okay, I will start with the right hand side of this equation. I will arrive to the left hand side of this equation by transferring this one into new form where we have more information. Okay, let's rewrite this one here. So cotangent x minus cotangent 2 to the n x equal cotangent x minus cotangent 2x plus, put the power 1 here, plus cotangent to the power x minus cotangent 2 square x. Okay, plus cotangent square cotangent 2 square x minus cotangent 2 to the 3x plus cotangent 2 to the 3x minus cotangent to the 2 to the 4th x plus cotangent to the 4th x minus cotangent to the 2 to 5th x. Okay, and so on until you get the last term. Okay, the last term is cotangent 2 to the n minus 1x minus cotangent to the nx. Okay, what I'm trying to do here I'm just adding something, subtracting something, adding something, subtracting something. In the first term, I'm subtracting cotangent to x, but then the term after is coming after. You will be added on this term in order to be cancelled out. Okay, so that's what I did here. So I subtracting cotangent to x from cotangent to x. I subtract the term after coming after. I subtracting cotangent 2 square x from cotangent to x. I subtracting again cotangent in the fourth term. I subtracting cotangent 2 to the 3x from cotangent to the 3x. Okay, and so on. Okay, until you get the last term. That's what I did here. Okay, so this one you will be cancelled out with this one, the first term. So cotangent to x will be cancelled with cotangent to x. Cotangent 2 square x will be cancelled with cotangent 2 to x. The cotangent 2 to 3x will be cancelled with cotangent 2 to 3x, and so on until you get the last term. The last term, as you see here before the last term, cotangent to x 2 to the 5x will be cancelled with a term coming after, as you have here. In the last term, cotangent 2 to the n minus 1 2 to the n minus 1 x, it will be cancelled out with the term before this one. What's left? Only cotangent x minus cotangent 2 nx, as I did nothing. Why am I writing this one on this form? To apply this equation that I have proved before. Okay, so now this one, what is this? Is 1 over sine 2x. Same thing, this one, second term, is a 1 over sine 4x. So this one is 1 over sine 4x. This one, 1 over sine 2 to the 5th x. The last term is 1 over sine 2 to the n x. Okay, so now what I'm doing, just I'm replacing every single term by this one. So let's call it as a capital A. Okay, so let's call it, let's put cotangent x minus cotangent 2 to the nx equal 1 over sine 2 to the x, which is the first term, plus second term, which is 1 over sine 2 to the 2x, okay, plus 1 over sine to the third x, plus 1 over sine to the fourth x, and so on, until you get the last term. Last term is a 1 over, as you proved here, 2x, you see, 2x, over 1 over sine 2 to the nx. Now my equation is proved. Thank you for watching. I will see you in next video. Bye.